Good morning all. So today we are going to talk about something called the Y-intercept of our graph. So what I'm going to do is I'm going to graph numbers 1 and 2 kind of quickly because there's a lot that we need to talk about. It's actually a very easy lesson, but there's a lot of kind of discovery that goes along with it. So I'm just going to graph numbers 1 and 2. So for number 1, and if you could do this on your own if you want to make your table. So those are going to be my points, which I will connect. And of course I'm going to use my arrows, and I'm going to label. And for my second one, these are going to be my points, which again, of course, I will connect and label and use arrows. So what is our y-intercept? Well, we'll see this in a couple minutes, but the y-intercept, to intercept means to cross, is where our line touches the y-axis, right? So here's our y-axis in orange. So let's take a look at my first equation. Y equals 2x minus 4 is my green equation, right? This is where it touches the y-axis. That's what we call the y-intercept. Now it turns out that the y-intercept of this equation, y equals 2x minus 4, is negative 4. That's where it goes across the y-axis. Let's look at my blue equation. My blue equation touches the y-axis right there at positive 6. So my second equation touches the axis at positive 6. So just something to keep in mind. It may not mean anything now, but just think about the connection that we've kind of just made there. Okay, vocabulary time, right? So it says the y-intercept of a graph is the y-coordinate of the point where the graph intersects the y-axis. For example, the graph of y equals 2x minus 9 crosses the x-axis, the y-axis, at the point 0, negative 9. So the y-intercept is negative 9. And again, we've got this connection that we make here. So you're going to pause and you can jot this down in your notes. All right, this does not need to be in your notes. I'm just going to kind of show you how we would find the intercept if we looked at a line. So I'm looking at this gray line over here, and it says, what are the x-intercept and the y-intercept? So the x-intercept is where this thing crosses the x-axis, which is here at 5, 0. And the y-intercept is the place where the line touches the y-axis, which is here at 0, 7. Okay, let's take a look at one more. Again, doesn't have to be in your notes. We're just kind of looking at this. So the x-intercept, again, is the place where it touches the x-axis. So this is my x-axis, so that's my x-intercept. This is my y-axis, so this is my y-intercept. Now, what did we notice, right? And again, this does not need to be in your notes. For all x-intercepts, right? So the x-intercept here was 5, 0. And here my x-intercept is negative 8, 0. The y-coordinate has to be 0. Because on the x-axis, any point on the x-axis will have a y-coordinate of 0. Then, of course, the opposite will be true. What about the y-intercept? Well, I had 0, 6, I had 0, 7. So my y-intercept is always going to have an x value of 0, because any point on the y-axis will be in the form 0, something. So how is that going to allow us to find a y-intercept from an equation? Okay, so here's our big takeaway, right? So we're not really concerned, at least not today, with an x-intercept. We will at some point, maybe towards the end of the year. But to find the y-intercept, right, on a graph it's easy. You just look at it. You look at the y-axis, you find the point where the line crosses over. But what if you just had an equation and you wanted to find the y-intercept? Well, we looked a little bit with the do now. We made some connections there. But let's take a look at this, right? For all the y-intercepts, the x-coordinate is 0. So to find the y-coordinate, the y-intercept, all we need to do is substitute 0 for x. So here's an equation. Where is this line going to cross over the y-axis? Well, if I graph it, I would see it, but we don't necessarily need to do that. If I want to know where it's going to cross the y-axis, I want the y-coordinate when x is 0. So that's something that would be worth getting in your notes. The y-intercept is the y-coordinate when the x-coordinate is equal to 0. So it's always going to be in the form 0, something. So how do I find out what that is? You substitute 0 for x. So if I substitute 0 for x, I get 3 times 0 minus 2. I get 0 minus 2. And then my y-intercept is 0, negative 2. So what's the connection that we made with the do now that we're making here? Every time we've done this, it seems like the y-intercept has just been the constant. Because if you've got slope-intercept form, which is y equals, well, we haven't talked about that actually, so let's hold off on that. If you have an equation solved in terms of y, it looks like the constant should work as the y-intercept. Let's look at another one. Okay, so we said we want to find the y-intercept. So the y-intercept is the y value when x is 0. So it's going to be 0, comma, we don't know. We said we can do that by substituting 0 for x. So if x is equal to 0, half of 0 is 0, and 0 plus 7 gives us 7. So when we say what the y-intercept is, we don't need to write it as a coordinate, right? Because we know it's always going to be 0, comma something. You could simply say the y-intercept is 7, or the y-intercept is 3, or the y-intercept is -2. Okay, so this one's going to be different. Okay, so if you look at our final answer at the bottom, and we look at what we have at the top, okay, the y-intercept is not the constant, right? The constant is -5 here. Now, why is it not the constant? Because we didn't solve the equation for y. So we always, as we see here, y equals. As we see here, y equals. We always want our equation solved for y. So thinking back to that lesson on literal equations, where we were trying to solve for x or solve for a or solve for b, the main reason we did that is so we can solve for y when we're graphing. So what do I need to do to solve for y? Well, I need to add 5 on both sides. So that's going to give me y equals 2x plus 5. So let's take a look at it. Now we can substitute for 0 for x. Now we find that my y-intercept is 0, comma 5, so my y-intercept is 5. So with regards to my new equation, this strategy still works. So what's the big takeaway from today's lesson? The big takeaway is if you want to find the y-intercept, right, without graphing, all you need to do is solve the equation for y and then grab the constant. Right? The constant is the number without the variable, and that will be our y-intercept. So we're going to put this in our notes as well, right? This is like the aha moment, whatever you want to call it. If our equation is in slope-intercept form, so what's slope-intercept form? Slope-intercept form means it's in the form y equals. Technically, it's what we call y equals mx plus b, but we're not going to talk about that yet. When it's solved for y, the y-intercept will always be the constant. So if I look at this equation, and somebody says, what's the y-intercept? It's very easy. The y-intercept is going to be -9. Okay, now the variable that we're going to use for the y-intercept is b. Okay, and we're not there yet as far as actually looking at slope-intercept form, but that's the variable we're going to use. So you don't have to write the y-intercept is, the y-intercept is, you're going to put b is. So for the first one, y equals 5x minus 3. That seems nice and easy. It's already solved for y. So my y-intercept, which I'm going to refer to as b, is -3. Right? It doesn't get much easier than that. Number 2, actually equally easy. My equation is solved for y. I'm going to say, where's my constant? That's +1. So b is equal to +1. Let's look at my third one. Right? There is no constant. Does that mean there's no y-intercept? It doesn't. There are going to be times that there's no y-intercept. They're very rare. I don't even know if we're going to look at them, but it may come up. So I'm going to say, well, what's the constant here? Well, I don't see a constant. Could I add a constant if I wanted to? I could. It would be a little silly for me to write y equals 5x plus 0, but sometimes I do that just to illustrate the point. Okay? That is going to be 0. What does that mean if the y-intercept is 0? Well, let's look at a graph. Well, if a y-intercept is 0, so this graph is going to look like this, it means it crosses through the origin, right? The origin is the point 0, comma 0. So that's an important connection that we make, that if there's no constant, it doesn't mean there's no y-intercept. It means that the y-intercept is 0, which means it's going to cross through the origin. Okay, let's take a look at the next one. Right, it says y plus 8 equals 6x. Well, I can't answer this question yet. Right, for the first time, at least of these three, my equation is not solved for y. So I need to solve it for y. I need to isolate my y term. So now I've got y equals 6x minus 8. Okay, now we've got it where I want it. So now I know that my b is going to be -8. Okay, let's look at the next one. All right, so let's see how much we remember about that lesson. Okay, and we revisited this when we were graphing linear equations for those 2 days. How am I going to solve for y? I'm going to divide everything by 5. So 5y divided by 5 is y. 2x divided by 5, since it's not evenly divisible, we're very happy to leave it as 2/5 x. And 15 divided by 5 is 3. So now finally we can answer our question. What's my constant when I solve it for y? It's 3. All right, so let's take a look at this last one. So when I solve the equation for y, I get y is equal to 5. Okay, so what does that mean? Well, again, how else could I write this? Well, there's no x term. So having no x term is equivalent to having 0 groups of x plus 5. Would I ever see it written like this? No, it's kind of silly, but again, I do this to illustrate the point, that the coefficient of x, if I needed it, would be 0. I don't even need what I've got in black, but let's go back to this. What's my constant? Well, my constant is 5, which means that b is equal to 5. Okay, so if we look at this one had no constant, meaning the constant was 0. Again, guys, a constant is just a number without a variable. My last one did have a constant. It didn't have an x term. I don't care about the x term. I care about the constant, and my constant was 5, so that's my y-intercept. So there's your now try. So you're going to pause. You're going to work these out in your notebooks. And then we'll come back. So the first one I gave you is a nice simple one. So b is -7. The second one we talked about before, right? If we look at y equals 5x, this is just y equals 1x. So again, if there's no constant, we see that the constant is 0. For the next one, I've got y plus 4 is equal to 3x. We said we need to solve this for y. So that's going to give me y equals 3x minus 4. So that should be pretty easy now, right? I know that my y-intercept is going to be -4. For the next one, we need to do some work. We need to solve this for y. So we're going to divide everything on both sides by 4. That's going to give me y equals, since 3 is not evenly divisible by 4, we said we're happy to leave it as 3/4 x. 20 divided 4 gives us 5. So there's my constant, so b equals 5. For the next one, right, what are we going to do? Well, if we have a fractional coefficient, we need to multiply by the reciprocal. This one's hard, right? And we need to multiply everything by our reciprocal. So we're going to multiply everything on both sides by 2. So when we get that, we get y equals 6x minus 20, and there's our y-intercept, right? Our y-intercept is -20. Now this last one is not, I don't think it's so hard, but it's 2 steps. So I don't think we've seen one yet that's been 2 steps, right? So what do we need to do here? Well, I need to isolate my y term. So I need to move my 6x, which gives me -3y equals -6x plus 12. Now I need to divide both sides by -3. And we're going to divide everything by -3. So -6x divided by -3 is +2x. 12 divided -3 is -4. So finally, I've got my y-intercept here after all that work, which is going to be -4. So guys, this is it. This is your homework. Find the y-intercepts. Okay, so you're going to write out each of these, and you're going to do whatever steps are necessary. Now, 1 and 2 don't really require any steps. The y-intercept is right there in front of your face. Number 3 involves some division. 4 involves some addition. And then 5 involves division. So does 6, 7, and 8 involve 2 steps. You need to isolate your variable term. And then in number 7, you're going to divide by 2. And then in number 8, after you isolate your y term, you're going to multiply by the negative reciprocal of -1/4, which is -4. So I've given you guys some pretty good hints. And for each of those, you can put b equals. So spoiler alert for number 1, you write your equation, and then you can just put b equals 1. All right, guys, as always, questions, comments, concerns, you post a comment on Google Classroom with your uploaded work, and I should be able to get back to you pretty quickly.